We're going to look at something called the addition rule and complements today. And it's a way to calculate probability when a couple of things happen at the same time. So first of all, we need to talk about the word disjoint. Two events are disjoint if they have no outcomes in common. We can also say that they're mutually exclusive. Those two terms mean the same thing, disjoint and mutually exclusive. And if you can picture a Venn diagram, if the circles overlap, then they are not disjoint. They do have something in common. Disjoint means they don't have anything in common. So we've got chips in a bag, and each chip is labeled from 0 to 9. And one of the events is choosing a number less than or equal to 2. The other event is a number greater than or equal to 8. And you can see our less than or equal to 2 is in the purple circle, and the greater than or equal to 8 is in the green circle. And numbers that don't belong in either circle, they're in the sample space. That's what the big blue rectangle is for. They're just not in the circle. So these two events, choosing a number less than or equal to 2, choosing a number greater than or equal to 8, are disjoint because they don't have anything in common. We would also say they're mutually exclusive. We can calculate these probabilities. The probability of picking a number that's less than or equal to 2 is 3 out of 10 because there's 3 numbers in that category. The probability of picking a number 8 or bigger, well, the number in that category is 2 out of 10. And the probability of picking a number less than or equal to 2 or a number 8 or greater is equal to the total number of numbers in those two categories divided by the total thing. So there's 1, 2, 3, 4, 5. That's where the 5 comes from out of 10. So either they came from this group or they came from that group. So we added those two together. And that's where this formula comes from. The probability of E happening, a number 2 or less than, plus F happening, 8 or greater. 0.3 plus 0.2 is 0.5. So you could actually calculate this two different ways. So here's my addition rule. If they are disjoint, they don't have anything in common, then the probability of E or F happening is equal to the singular probability of E plus the singular probability of F. And it doesn't matter how many events we have. If they're all disjoint, then we can take their individual probabilities and add them up. So from yesterday, we can see this is a probability model. It all adds up to 1, and each one is in between 0 and 1. And we can answer questions like this. What's the probability that a randomly selected housing unit has 2 or 3 rooms? So that's the probability that it has 2 rooms plus the probability that it has 3 rooms. What's the probability that it has 1 or 2 or 3? Well, because those are all disjoint, there's no overlap there, we add those 3 probabilities together. Now, what if they're not disjoint? Or maybe we don't know. Then we do add the individual probabilities together, but we have to subtract the probabilities of where they overlap. In formula terms, we say the probability of E or F is equal to the probability of E plus the probability of F minus the probability of E and F. Okay, so we've got 2 dice, and we're looking at the sum of the dice that we get when we roll them as a pair. So event E is the first dice is a 2. Event F is the sum is less than or equal to 5. So we do have some overlap there. The first die is a 2. That's everything in this second row right here. And then event F, the sum of the dice is less than or equal to 5. Well, that's going to be all of the numbers on this upper left half where the red die, well, that's not true either. I was going to say the red die is a dividing line, but it's actually this one right here.